Okay, so this is going to be part 3 of the lesson on combination and permutations, and this is a mixture of combination and permutation problems. All right, so number 1, we have 7 banks have volunteered to perform at a bands, that should be bands, sorry. 7 bands have volunteered to perform at a benefit concert, but there is only enough time for 4 of the bands to play. How many lineups are possible? All right, so keep in mind we're talking about lineups here. Just like in a baseball game, you have the order of batters. So band A, B, C, D, let's say, would be a different lineup than, let's say, band A, C, B, D. So those would be 2 different lineups. So in this case, the order matters. All right, so the order matters. So this will be a permutation problem. And so we're trying to find the number of permutations of, and we have 7 bands, and we're choosing 4 at a time. All right, so using your calculator, hopefully this is not going to be a very huge number in terms of, remember in previous lessons we had numbers that were in scientific notation. So hopefully we're not going to have any in here. So let's see what we get. So remember we put 7 first. All right, so 7. I'm trying to make sure the light's not in this place, and it is. All right, so 7. And then we press probability. And we're looking for permutations. That's what I need. Press equal, and then 4. And then press equal, and we get 840. So there are 840 possible lineups. Okay? All right, number 2, an election ballot asks voters to select 3 city commissioners from a group of 6. In how many ways can this be done? Now in this case, remember you're just selecting a group of 6. Does not matter in the order in which you select them. So that's going to be a combination problem. So order does not matter. Okay, order does not matter. So the order in which you select these 6 individuals does not matter. So this would be a combination problem. So it would be a combination of, let's see, a ballot, I selected 3. All right, so we group combination of 6 candidates, and then you're choosing 3 from those. All right, and so using your calculator, so you're going to say 6, then probability. You need the combination part. Press equal, and then 3. Press equal, and there are 20 ways in which you can get a group of 3. Okay? All right. To win the small county lottery, one must correctly select 3 numbers from 30 numbers. So we're assuming the numbers are 1 through 30. All right? And the order, really it doesn't matter, just as long as they're distinct numbers. The order in which the selection is made does not matter. All right, so they tell you right away that's a combination problem. How many different selections are possible? So you're going to say combination of 30 items, taking 3 at a time, and that's going to equal, so 30, probability, there's a combination problem, press equal, 3, press equal, so 4,060. All right, number 4. A corporation has 10 members on its board of directors, and how many different ways can it elect a president, vice president, secretary, treasurer? So here, the order does matter because you're selecting 4 people, right? All right, so 1 person must be a president, 1 person must be a vice president, 1 person must be a secretary, 1 person must be a treasurer. So the order does matter. So it has to be a permutation problem of 10 items, 10 members, and you're selecting 4 in a particular order. President, 1 must be a vice president, 1 must be a secretary, and 1 must be a treasurer. So 10, probability, I'm sorry, permutation rather. You need a permutation one, and then 4, press equal, 5,040. Okay, in number 5, here you're looking for distinguishable permutations. Now remember the formula for that is this. So if you have repeating repeating letters, then the formula would be n factorial, the number of letters altogether, divided by, and then the number of repeating letters. So p factorial, q factorial, and so on. Remember that? Okay. Now here there's no repeating letters. So basically you're just trying to find how many words you can make from these letters. Okay, so 1, 2, 3, 4, 5, 6, 7. So if you think about it, it's really a counting problem. So you have 7-letter words, right? Okay, 1, 2, 3, 4, 5, 6, 7, basically. And so they're all different. None are alike. And so you'd say, well, there's 7 letters for the first, 7 choices of the first letter of my word. Then once I choose one, there's 6, and so on, right? So this is just your numerator. That's just n factorial. So this is just 7 factorial. All right, so all of the denominators would be 1 factorial, 1 factorial, 1 factorial, and so on. All right, so 7 factorial on your calculator gives you 5,040. Okay? All right, over here, though, now that's where we're going to use this, because I do have repeating letters. So altogether, though, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial divided by, there are 2 letter A's, so that's 2 factorial. And there are 2 letter R's, so that's another 2 factorial. And that's all the repeating letters. So all the rest are just 1, so it's 1 factorial, 1 factorial, and so on. But we don't include those. So in your calculator, though, remember how we did this. So in your calculator, you want to enter it as this. So you want to enter it, since I have more than one factor in the denominator, you want to put that denominator in parentheses. Now this, though, it's easy enough to where you really didn't have to do that, because you know what 2 factorial is, right? You know what 2 factorial is. What's 2 factorial? Well, 2 factorial means 2 times 2, so that's, 2 times 1, so that's 2. So this is 2, this is 2. So that's 8 factorial divided by 4. So you can use your calculator that way. So basically, since this was easy enough to figure out, you can now just say this. So you're going to say 8, then go to probability, go to the factorial symbol, press equal, and that's 40,320, but then you can divide that by 4. So divide by 4, and you get 10,080. So this will be 10,080. Okay? So you can make 10,080 different words from aberrant. But if you use this, I'm going to just show you how to do that, though. You should get the same thing. Just make you put the denominator in parentheses. So you're going to say 8 factorial, just like that, divided by parentheses 2 factorial times 2 factorial, close the parentheses. See how that looks? 8 factorial divided by, in parentheses, 2 factorial times 2 factorial. Press equal, and you get the same thing. Okay? All right, so that's number 5. Okay, number 6. Mr. Jones owns 4 pairs of, 4 pairs of pants, 7 shirts, and 3 sweaters. In how many ways may he choose 2 from the 4 pairs of pants, 3 from the 7 shirts, and then 1 from the 3 sweaters? All right, so basically you have your, no, this will be partly counting as well, so you can use your counting principle. So this will be the number of choices for the pairs of pants times the number of choices for the shirts times the number of choices for the sweaters. Now remember, the order in which you pick the pairs of pants does not matter. So basically this is going to be a combination problem for each of these parts. So this is number of combinations of 4 pairs of pants. You're choosing 2 of them, times the number of combinations of 7 shirts, and you're picking 3 of those. And then the the number of combinations of two pairs, three sweaters rather, three sweaters, and you're choosing one, okay? So using your calculator, you're going to find out each of those. So in your calculator, you're going to say this. You're going to say 4, probability, combination, 2, times 7, probability, combination, 3, times, and then combination of 3, one at a time. So 3, probability, combination, equal, 1, and then press equal, and you get 630. So there are 630 ways I can choose 2 pairs of pants from 7, 2 pairs of pants from 4, 3 shirts from 7, and then 1 sweater from 3. All right. Okay, so number 7, a multiple choice test consists of 15 questions, each permitting choices of 5 alternatives. In how many ways may a student fill in answers if they answer each question? Okay, so this is a combination problem because the order in which you answer the questions does not matter. So this is combination of 15, choose 5, and that's going to equal, let's see, combination of 15, choose 5, and that equals 3003. All right, so 3003. All right, so those were just extra problems based on what we did in parts 1 and 2. So these are just more problems. It's just mixed up though. And so that should help you. Those 3 parts, parts 1, 2, and 3, should now help you with My Math Lab and the worksheet. Okay? All right, so that's going to take care of this part of the lesson, part 3.